Okay, so our first slide in our presentation, Station 1, for this week's Integer Exponent Chapter 6 work in Algebra and both Liberal Arts, says here, evaluate each expression for the given values of the variables. This is actually quite easy, and again, it is our warm-up. So what they do is they give us a term. Here, it's x to the third times y to the second, and they tell us to evaluate for x when it's -1, and y when it's 10. So we're going to use the -1 and 10, and we're just going to fill in substitute those terms for these variables. Again, x -1, y is 10. So I'm going to rewrite that. I had x to the third times y squared, and they said to use -1 for x, keep the power of the 3, times 10, which is what they said to substitute 10 for y, squared. Now I have to go through and simplify these. So -1 to the third power means -1 times -1 times -1, which is -1, because 1 times 1 is 1. -1 times -1 is +1. +1 times -1 now yields a -1. Remember, we still have to simplify over here for our y squared, which turned out to be 10 squared, which is 10 times 10, which is 100. 10 times 10 is 100. Now I just want to simplify here. I have -1 times 100 is -100. 1 times anything is itself, and we keep that negative sign. So here we would see that -100 is our answer for example 1. The second example looks kind of creepy. It's 3x squared over y squared. I'm going to write that one here on the board for you. 3x squared over y squared. In this problem, what would creep people out a little bit is that you have this fraction. You have an exponent up here in the numerator, and you have an exponent down here in the denominator. However, they are telling us to substitute. Where we see x, we're going to put a 4, and where we see y, we're going to put -7, in parentheses, notice. So here, where I see x, I'm going to put a 4, so that's 3 times 4 squared. All I did was change the x to a 4. I did put a times symbol in between it, because otherwise, if I wrote it like this, it might look like 34 squared. That is a wrong way to write it. So here, y, they said, since it's over, we're going to use -7 in parentheses for y and keep the squared on there as well. Now we just go ahead and simplify both the top and the bottom by doing the workout. So here, we have 3 times 4 squared. Well, by order of operations, we have to do 4 squared first. 4 squared is the same as 4 times 4. 4 times 4 is 16, so I have 3 times 16. See, this entire 4 squared is where I got that 16. Over, well here, -7 squared is -7 times -7. I'm using this entire thing, including the parentheses, because that's how the problem presented it to me. And I want to make sure that I'm always recording the way the problem presented to me. -7 times -7, well, 2 negatives is a positive, and 7 times 7 is 49. My last step here looks like I just have to simplify 3 times 16. Well, 3 times 16, that's 48 over what we already had was 49. Looks to me that 48 over 49 is already written in simplest terms, and that would be your final answer. So I will put here 48 over 49. Okay, heading down towards the bottom of this paper, we have a problem here where it basically tells us, well, there's 2 examples. They want us to rewrite each number as a power of the given base. So the number 64, they want us to know if your base was 4, what would be the power that gets attached, or the exponent, to the 4? That would equal out to 16. Here's what I do. I work backwards. I say, well, I know that 4 times 4 is 16. And then I also know that 16 times 4 is 64, which happens to be the number that I'm looking for. So how many times did I multiply 4? 4 times 4 times 4. There were 3 times, so that makes my power or my exponent up here to be to the 3rd power. That's exactly how you do that. The same thing here on number 4 says negative 27. How can I get to negative 27 using a base of negative 3? Meaning, what exponent would I put here that it would equal negative 27? Well, I know it's either, so if I start, I would say negative 3 times negative 3 is a positive 9. I notice also that 9 times 3 is 27, but that's positive, but I'm using negative 3 here. So times negative 3, positive 9 times negative 3 would give me a negative 27, which is what I was looking for. So I used that negative 3 times. Negative 3 times negative 3 times negative 3 gave me an answer of 27, so it was, again, to the 3rd power. That's just coincidence to the last example. Again, this is our warm-up. Here we went through and we substituted, and then we just solved, did the work out for the same for number 2. We didn't get thrown off that there was a fractional bar. We just substituted both for the top and the bottom, the x and the y, did the math out and got a final answer. And then what we did down here was we took our original number given, the 64. They asked us to find a base of 4, and we had to figure out what would the power be by multiplying out a certain amount of times and figuring out which one worked. In this case, 3 worked here, 4 to the 3rd was 64, and 3 also worked down here. Negative 3 to the 3rd power gave us negative 27. You're now ready to move on to the lesson, starting at the objective. So you can continue on with the video, press pause if you need a little break.